As machine learning models evolve and grow, there are many different ways in which machine learning models are categorized. But the most common kind of classification or categorization is to divide machine learning models into two categories: supervised learning techniques and unsupervised learning techniques. And these are terms that you'll hear very often when people talk about machine learning. So let's really understand what these two terms mean. There are two categories of machine learning problems. The first is supervised learning. Supervised learning techniques involve the use of labeled data that is used to train the models and improve the model's parameters for prediction. The training data used in supervised learning contains not just X variables or features, but also Y variables or targets. That is the value that the model is trying to predict. And the model's job is to learn the relationship between the X variables and the Y variables and try and make these prediction on unseen data. You cannot work with supervised learning techniques unless you have labeled data. Now, unsupervised learning techniques are techniques that you use when labeled data is not available. The model is set up and structured in such a way that it's able to learn from the data itself. It doesn't need labels to improve its performance. The data used to train such models only contains X variables or features. Y variables or targets that you might want to predict are simply not available to you. This means that the model has to look only at the data available, that is the X variables, and use this to identify patterns in the data to learn from the data itself. Let's talk about supervised learning in a little more detail. Now, supervised learning tries to solve a problem of the form y is equal to f of x. X here refers to the X variables or features that exist in the data, and Y represents the Y variables or the targets. The objective of supervised learning is to figure out what is the relationship that exists between X and Y. How can you use the values that you have for X to predict Y? The objective of the model is prediction. This is where the training process uses the Y values that are available in the training data to improve the model's parameters. So the model looks at both X and Y values during training and then finds patterns that allow it to figure out the relationship between X and Y. So the objective of the model is to reverse engineer the relationship between X variables, the features, and the Y variables, the target. The parameters of the model that are tweaked during the training process try to figure out this relationship F. The better it's able to map this relationship, better the predictions from the model. It's pretty obvious that if you're trying to reverse engineer this relationship, it's very, very important that you have labeled data to start off with. So, getting labeled data is an important pre processing step to training models that work using supervised learning techniques. Now, there is an important problem here. Getting labeled data is easier said than done. Labeling data is often a manual, time consuming process. So, there are automated tools and techniques that are available. They're not perfect, especially the quantity of data that we'd like in order to train these very large models that perform complex tasks. It's impossible to really use labeled data in all of these use cases. Labeled data is a very small fraction of the actual data that's available in the real world, and this is often a limiting factor when you're using supervised learning techniques. But as a student of machine learning, this is the first category of problems that you'll seek to solve. The very first kind of machine learning algorithm that you're likely to use is regression. And regression is a supervised learning technique. Regression is when you use a model to predict continuous values, such as the price of a stock, the mileage of a car, or what the temperature might be like tomorrow. Classification is also a supervised learning technique when you predict a discrete class or category at the output. Image recognition problem: is this a dog, cat, or a plane? That's an example of classification. That's a supervised learning technique. Sentiment analysis: is this review positive or negative? Again, supervised learning. Now that we've understood supervised learning, let's turn our attention to the other category, unsupervised learning techniques. These are typically used when we do not have labeled data. The model itself is structured in such a way that it's able to find patterns in the X variables, that is, the features that are present in data. As you might imagine, the training process of such models tend to be different because there are no labels available to improve the performance of the model. The model cannot look at the prediction that it has made, compare it to the actual labels, and see how it can improve. It has to just look at the data that it has and find patterns in that data. In unsupervised learning techniques, model focuses on intrinsic patterns that exist in the data and does not seek to reverse engineer any kind of relationship. Unsupervised learning techniques are actually very, very powerful because most of the data available in the world today is unlabeled. So, learning to work with unlabeled data can produce very powerful models. Just like regression and classification are examples of supervised learning techniques, clustering is an example of an unsupervised learning technique. With clustering, you only have the X variables, the model looks at the data and finds logical groupings in the data. It identifies data points that are similar to one another and places them in the same cluster or group, and data points that are different from one another are placed in different clusters or different groups.